So, we have another video when we talked about addition polymers, and you're gonna find the link to that video in the description. Uh, Addition polymers comes from repeated units of monomers, which are alkenes, and they are only formed of one unit, one molecule, which is repeated so many times, and there is only one product of the addition polymers. Condensation polymers is a bit different because in condensation polymerization, a small molecules is formed as a byproduct. So we don't only get the polymer, but we get another small product. And each time a bond is formed between two monomers, a new small molecule is formed. In this case, we don't only have one monomer. The monomer we have is not only formed from one molecule, but it's formed by the condensation reaction between two different molecules. And condensation means a loss of water molecules. So the small molecules here is going to be water. So what kind of molecules do we expect to see this condensation polymer? We expect to see this if we react um, an alcohol, alcoholic a molecule that has a diol functional group or has two OH groups like this one. And then we have another molecule, another monomer, which has two carboxylic acid group. Okay, and then we're gonna repeat these units. So we have another molecule of dihydroxy and then another molecule with two carboxylic acid group. What happens is a condensation reaction. In a condensation reaction here, when we have an alcohol and a carboxylic acid, they will react together, and then there will be a removal of a water molecule. So, and each of these, you're gonna keep removing a water molecule between two adjacent molecules. And then what happens is that you're gonna remove water molecule from each of these as the reaction goes on. So one water molecule from each and so on. And then you're going to end up with your polymer, which is a repeated unit of the ester. So you have the alcohol and you have the carboxylic acid, and this is the repeated unit basically. So as you can see, this is the repeated unit, and it keeps repeating every time like this. So this is the same repeated unit, and this is the ester functional group that has been formed, or the ester link between the alcohol and the carboxylic acid. So these are called condensation polymers. PET is a polyester that is made from terephthalic acid and ethane 1,2-diol. So the dicarboxylic acid compound we have here is the terephthalic acid, which has two carboxylic acid functional group. And then the alcohol is the ethane 1,2-diol, which has two alcoholic group or two OH group. And then the condensation reaction or condensation polymerization will take place where a water molecule is removed here, and then you're gonna make an ester link. So this is the new ester link between the two molecules, and then we're gonna repeat the same units on both sides. When you draw the polymer of the condensation polymerization, remember again that you're gonna do the same as the addition polymer, where you're gonna just draw one monomer or one repeated unit, which is formed of the two different monomers. And then on one side, you're gonna leave the carbonyl group of the carboxylic acid and the link. On the other side, it's the oxygen from the alcohol on the other link. Don't forget that you're gonna have to draw the ester link in between, and then you're gonna draw the brackets and then put the letter N, which means this is the repeated unit. It's repeated n number of times. And don't forget to also draw the small molecule, which is the hydrogen. So we're going to have n number of hydrogen molecules that are released. So when you write the displayed formula of a polyester showing the repeated unit, so from the monomer, you need to identify the hydroxyl group from the carboxylic acid, the hydrogen from the alcohol that will be lost and joined up the molecules, and then you need to join up the molecules at this point. Then the repeat unit is simply going to be one of each diol and the dicarboxylic acid, which will be joined together with a bond sticking out at each end, the same as for the polymers. So we're going to have the exact same thing as we did for the addition polymers. So disposal of these polymers for condensation polymers is easier than the disposal of the addition polymers because condensation